And another one of my 2020 distance learning videos on parabolas. This time we're going to graph a parabola using the intercept form, which is y equals a, and in brackets x minus p, times in brackets again x minus q. Here we go. Today is about graphing parabolas or quadratic equations when the formula is in this form here. Now this form has got a special name. A, x minus, and the blanks are x minus p, x minus q. And this form is called intercept form. Okay, so it also appears here in this first question, intercept form. And what intercept form is, we have these two numbers p and q. A is the same as it always is. If A is positive, that means it opens up. If A is negative, it means it opens down. And if A gets larger, then it gets skinnier. All right, it stretches away from the x-axis. And if A gets closer to 0, it shrinks towards the x-axis. What P and Q are the x-intercepts. So the x-intercepts are these values, P, 0, that point, and Q is 0, that point. So once we know what P and Q are, we have the two x-intercepts. And that's what today is all about, this intercept form. We get it into intercept form, we find P, we find Q, then we have the x-intercepts and we graph it from there. Okay, so we're going to do it in this order. We're going to write this in intercept form, and then we're going to find the x-intercepts and show it on the graph. So we're going to have an equation here. If we're going to find the x-intercepts, what do we normally do? If we're going to find the x-intercepts, we let y equal 0. Just bear with me. And then I get this equation with y equals 0. 0 equals x squared minus 3x minus 4. Now, does that look familiar? We did this in chapter 9. This is solving a quadratic equation. And we've got a trinomial. What do? 0 product property. Can we get 0, so we've been doing this over and over again in chapter 9. Can I make this look like this? Something times something. And then solve it for x? Let's try it. We need two numbers that multiply to give -4 and add to give -3. Can you think of what they are? Pause me. Go ahead and get the answer before I do. Did you get it? 4 and 1. And when they add together, so the multiplication, the product is negative, which means one must be negative, one must be positive. And they need to add to give -3, which means the -4 is going to be greater. Plus 1. What do we do then? We then get two answers, don't we? We've got 0 equals something times something. So this must be 0. Or this must be 0. This must be 0, x minus 4 must be 0, or x plus 1 must be 0. And then that tells us that x equals 4 or x equals -1. And they are our x-intercepts, okay? So the x-intercepts are 4, 0 and -1, 0. But it said get it into intercept form. We didn't actually do that, okay? I just wanted to explain this very clearly. What we could have done is instead of letting y equal 0, we could have just left the y here. So if I did that, I just left y there, didn't put y equals 0, and I factored the right side, I would end up with this. X minus 4, x plus 1. And that is actually intercept form right there, with the y still in it. Okay, and I just don't think the textbook explains this strong connection that it has with chapter 9, okay? We did that in chapter 9, and we can use that to find the x-intercepts, okay? But there you can clearly see that x minus p, so what's p? P is 4, okay? So this is actually your p value here. And this is tricky, x minus, if I'm going to write x plus 1 as x minus something, that would be x minus -1, wouldn't it? So q is actually -1. So that's p, and that's q, like I said there. The x-intercepts are p0 and q0, okay? 4, 0 and -1, 0. So that is intercept form, and our x-intercepts are p and q, 4 and -1. Let's show them on our diagram. So the x-intercept is 4, here's one of them. And the other one is -1, let's show that as well. Okay, our two x-intercepts. And if you like, you can even write p and q there I think that might help. P is there, and that's Q there as well. Or you can just say x-intercept. Next thing, we're going to find the axis of symmetry. So last time, what was the formula for the axis of symmetry? Do you remember? When we had y equals ax squared plus bx plus c, that's called our standard form, I think. We did x equals minus b over 2a. That's our axis of symmetry. But when we got this form, we approach it a different way. So by the way, is this parabola going to open up or open down? Here we've got a. What's a, by the way? There's nothing at the front there, which means that's actually a 1. And that means that's actually a 1 there as well. So for this question, we have a is 1. And if a is 1, is that positive or negative? That means that a is greater than 0. This parabola is going to open up in the end when we get to that. So it's going to open up. Okay, and where's the axis of symmetry going to be? The axis of symmetry, you could probably figure this out instinctively, it's going to be right between these two. Okay, it's going to be right between P and Q. So when we have our intercept form, the formula for the axis of symmetry is different. The formula is, probably thinking this is going to be scary. It's not. It's just the average of P and Q. It's going to be right between P and Q. How do we find the average? You add the two numbers and you divide by 2. So when we have intercept form, that's how we find our axis of symmetry. We find the average of P and Q. So what is it here? It's just P is 4, Q is minus 1 over 2. What's that? 4 plus negative 1 is 3 over 2. X is 3 over 2. Where's that? Let's write it as a mixed number, 1.5. Our axis of symmetry is the equation. Remember, the axis of symmetry is not a point, it's an equation. Axis of symmetry is the line x equals 1.5. And let's show it. Okay, so that's going to be a vertical line through x equals 1.5. Here I go. And done. Remember, a dotted line for the axis of symmetry. And we'll put our arrows going up and down. Let's write the equation of it. X equals 1.5. Okay, so that is our axis of symmetry done. We can even put that there if you like. 1.5. Okay, that's part A and B to this question. We're only doing the one question today. Let's move on to part C, see what they ask us. The next thing we're asked is find the vertex and show it. So we've got our axis of symmetry. Vertex is, remember what that is? It's a point on the axis of symmetry. That's always the lowest point or the highest point on the parabola. So how do we do that? Well, we take our value for axis of symmetry, which is an x value, x equals 1.5, and we put that into the formula. Okay, so I've got our formula here. I changed it to our intercept form. So we can put that in. Y equals, so the vertex is going to simply be, the x value is going to be 1.5, and the y value is what we're looking for here. We just put it back into the formula. Okay. They gave us that standard form before, but we want to work with our intercept form today. So we're going to put x equals 1.5 into this. 1.5 minus 4 times 1.5 plus 1. Ew. What's this going to be? 1.5 minus 4 is, so how can we do this using our fraction? So 1.5 is 3 over 2 minus 4, and 3 over 2 plus 1. Hopefully our fractions are good. So 3 over 2 minus 8 over 2, that's going to be minus 5 over 2, times 3 over 2 plus 1, that's 3 over 2 plus 2 over 2, that will be 5 over 2. And that gives us, sorry, I'm going to run out of space here, minus 25 over 4, which is what? 6 4s are 24, negative 6.25. So our vertex is, and make sure you say this clearly, don't stop there. The vertex is the point with coordinates 1.5, negative 6.25. Okay, make sure that's clearly written somewhere. That's our vertex. And let's write this. So let's show it on our diagram here. 1.5 on the axis of symmetry. Where's negative 6.25? So there's negative 6, there's 6.5. I guess it will be about here. So let's write that clearly, okay? And I'll write the coordinates next to it. Negative 6.25. vertex. If you're not sure if you should label something, then just label it, okay? Next thing, y-intercept. Let's find the y-intercept. Y-intercept is, so how do we always find the y-intercept? We put x equals 0. So putting x equals 0 into the equation, we get y equals, and this is actually quite easy, 0 minus 4 times 0 plus 1. Y equals, and this is going to be minus 4 times 1, which is minus 4. That's easy. 0, negative 4. And I think the original question gave you the formula in the standard form, right? What was the C? Just go back and have a look. Was C negative 4? I think it was. Go back and have a look, and it's just good that it all agrees, right? So our y-intercept, 0, negative 4. 0, negative 4 is right here. There is our y-intercepts. And with that, we can actually plot another point, can't we, using our axis of symmetry, okay, and that mirror line, as it is a mirror line. So we've got negative 4, 1.5 to 1.5. If I go another 1.5, that will put me at 3 with the same y value. That gives us another point here, 3, negative 4. Okay, does that make sense? You've got 0, negative 4. Mirror that point on the other side of the axis of symmetry, and that gives us a point 3, negative 4. Okay, just a little counting involved there. So that gives us, how many points do we have now? 1, 2, 3, 4, 5. That is more than enough to draw a parabola. I think we're about to be asked to draw it. So yeah, y-intercept taken care of there. There it is. Let's draw the parabola now, okay? So just do it nice and smooth. Remember, draw it all the way to the top of the window, okay, right where the arrows are on the y-axis and the axis of symmetry. Nice and smooth, no sharp corners, make sure it doesn't bend back in. Okay, it keeps going out wide. It gets straighter and straighter. It never goes vertical, it just gets straighter and straighter. And just do your best. Okay, and there is mine. I'm quite happy with that. That looks pretty good, I think. So it opens up, doesn't it, like we thought. A is positive 1, like we said before, which means it opens up. And that is done. Let's write the equation next to it. I might write the original equation that they gave us, okay? So y equals x squared minus 3x minus 4. And like we said, that is A is 1, B is negative 3, C is negative 4. Yes, that agrees with it, doesn't it? F. Nearly finished. State the maximum or the minimum value. Quick question, does this have a maximum value or a minimum value? So it goes on forever upwards, doesn't it? So it doesn't have a maximum value. This has a minimum value. And what is it? Do you remember from last lesson? The minimum value is always the y-coordinate of the vertex, which is negative 6.25. So here we have a minimum value, negative 6.25. Okay, whatever the lowest y value is. Okay, it's kind of like saying the lowest output value of this function. It has a minimum value of negative 6.25. Nearly finished. We're just going to do one last question here. And G, we're going to do something just like last lesson when I got you to pick when I gave you a random x value and just see if you can find another point on the parabola. So G, just like last time, remember how to do it? Pause me and go ahead if you're confident. Put x equals 2 into the equation to find another point and show it. So we're going to take x equals negative 2. I got an idea. I might make this the add it to the comment question, okay? I'm not going to finish it for you. X equals negative 2 means the point is going to be like this. Point, negative 2, and some y coordinate. Put it into the equation. So we're going to put x equals negative 2 into this, and let's use our intercept form. Y equals negative 2 minus 4 times negative 2 plus 1. Using your order of operations like our BEDMAS or our PEMDAS. Remember, we've got a multiplication here. You don't need to use FOIL here, okay? Just do the brackets first and then multiply the two numbers. What do you get? And then take that value, that is your y coordinate of the point, and put the point up there in the diagram. And does the parabola pass through it nicely? If you've done this correctly, it should. What are the coordinates of this point here? It should fit nicely on your parabola.